So this video is about U-substitution. It's usually the first integration technique that students are taught in a college engineering school. And basically what's going to happen is you're going to be given some equation that you have to anti-derive, and you're going to have a whole bunch of techniques, the first being U-sub, but a whole bunch of techniques: integration by parts, trig sub, trig integrals, partial fraction decomposition. You'll have to take a look at this equation you have to anti-derive and figure out which technique is the best to try to anti-derive this equation. That's the general feel of the techniques of integration chapter of a calculus class. Of course, before watching this, you want to know in general what an antiderivative is, but you especially want to know what the chain rule is, the chain rule of differentiation. Because U-substitution, is just the chain rule in reverse. Just like if someone asks me to anti-derive x squared, I can simply do the power rule in reverse to get this. Well, U-substitution is just chain rule in reverse. And let me show you what I mean there. So let's say I had to derive the following equation. I would use chain rule to do it because I have a chain of functions. I have a inside function, I plug in an x, it gets cubed, and that output leads right into the outer function, the sine. And one way to think about the chain rule is you take the derivative of the outside and multiply it by the derivative of the inside equation. So the derivative of my outside is going to be cosine, because we know this derivative of sine is cosine. But you got to remember that that inside function, that x cubed, follows down with it. And of course, times the derivative of the inside, that's going to be a 3x squared. So chain rule is the derivative of the outside with the inside of it times the derivative of the inside. So if you are asked to derive some equation and you think you can spot the inside and then also the derivative of that inside, this means that U-substitution is the technique you should use to anti-derive that equation. U-substitution is the inverse, the undoing of the chain rule. Let's look at an example to illustrate this. So let's say we had to anti-derive this equation. So maybe I can use U-substitution on it, and we'll talk about why it's called U-sub in a second. Well, I know if I'm going to use U-sub, I got to be able to spot something that looks like an inside somewhere, that's this guy, as well as the derivative of that inside elsewhere as well, getting multiplied somewhere. So, if I'm really looking, this guy right here looks like the inside, and that's 2 plus x to the fourth. Derivative of that is an easy 4x cubed. Well, here's an x cubed. It's not 4x cubed, but it is x cubed. And I'll show why the 4 doesn't exactly matter, but this is looking pretty close to the derivative of that inside. So this shows us that U-substitution is the way to go here. So because my inside is 2 plus x to the fourth, that is what I make my U. U basically just means the inside. So from now, the name of the game is to get all the x's out and put the u's in. That's why it's called U-substitution, or substituting. We're trying to get the x's out and u's in. So all these x's gotta get out of here, and that dx has to get out of here too, and we'll go over that in a second. So if I write my equation again, I put that u in there. Instead of 2 plus x to the fourth, I have a u now. But I still have to get rid of these x's, and especially this dx. Well, remember, these remaining things are kind of like the derivative of that inside. So we take the derivative of our inside, our u, to get that dx to appear. So we made dx appear, but it's in the denominator, so that's not very helpful. We're going to multiply both sides of the equation by dx. It cancels out on the left, and on the right, we get dx. So now we have an x cubed and a dx, just like we have here, so that's looking good, but we don't have a 4 anywhere here. That's no problem. I'm just going to divide 4 on both sides of my equation here. So now over here, essentially, I have an x cubed times a dx, and over here, x cubed times a dx. Instead of writing x cubed times dx over here, I can just write 1/4 du. So that's what I'll do. So now, I've successfully gotten all my x's out and replaced them all with u's. So the u substitution is complete here. And now the integral I'm left with is actually super easy. It's just an inverse power rule. That'll be u to the 6 over 24 plus c. And for my final answer, since the initial question had x's in it, I want my final answer to have x's in it. So basically, I just take that initial u, that initial inner substitution choice that we made, and put that back in. So instead of writing u to the 6th, I'm going to write 2x to the 4th, all raised to the 6th, over 24 plus c. And this is our final answer right here. So that is how you use U-substitution. And just to summarize, you use U-substitution if you see an inside as well as the derivative of that inside in your equation. So in our problem that we did, we saw an inside, and that was our u. The u is just the inside. And we took the derivative of that u because we saw the derivative of that inside. So basically, once you found your u, once you found the inner and the derivative of that inner elsewhere in the equation, like we see here, the name of the game is rewriting your equation. Get all the x's out of there and the u's in. And what you'll end up with is an integral that's a lot easier to do. So this is the basic concept of U-substitution. I have a practice video where we go through a lot more practice examples so you can really see this concept at work.